Okay, this video is over layer 4 of the OSI model, which is the transport layer. Some information about that is the PDU is segments. The purpose of the transport layer is to manage network traffic between devices and, if necessary, to ensure intact, complete delivery if desired. That is, to make sure all the packets show up, that they show up in order, etc. Components at this level, we usually don't talk about this in 161 or 160. About these specifically, we talk about these devices, but at least I don't personally mention that these are layer 4 devices. At layer 4, to get packets to and from their destination, we have IP addresses and we have port numbers to specify applications or services that are running that we want to connect to. And the two most common protocols at this level are TCP and UDP. Now then, as far as the packet we were been looking at was a UDP packet. So the UDP datagram format is this. We have a source port, which is the port that was randomly generated for the source to use as the endpoint of communications. The next thing we have is the destination port, which is the port we wish to connect to on our destination machine, which, for example, might be port 80, a well-known port for HTTP. We have a length of the data. We have a checksum for the header, and then we have data, which can be 0 to 65,535 bytes. Going back to the Wireshark capture that we've been looking at, we have things shown here. The first thing to notice is the first 2 bytes are the source port. It was randomly generated. The next thing we have is the destination port, which is often a well-known port, and port 53 means that we're talking about DNS. So this is a DNS packet. We have the length, which is 43. If you look over on the left side of the window, you can see that the source port and the destination port have been decoded for us and that the length is 43. Then we have the checksum, which is there. So that is the header portion of the UDP packet that we're looking at. Everything after the header is the actual datagram, which is DNS. DNS is an application, so it's an upper level or upper layer, or layer 5, 6, and 7, different ways to say the same thing. So we will go through and look at that in a little more depth. The other possible thing that we have at this layer is TCP. So the first thing we have is source port, destination port, just like we do in a UDP. But since TCP is the way that you get guaranteed delivery, we're going to have a sequence number and an acknowledgement number that we will talk about that were not included in UDP because UDP is best effort. We have a header length, which is 4 bits. We have 6 bits that are reserved, and then we have 6 bits of flags. And then when we talk about sliding windows, we have the window size, a checksum, an urgent pointer as to how urgent this message is. We may have some options and then we're going to have our data. So the data field in a TCP packet is the same size. We just don't have all this extra stuff that deals with flow control and acknowledgments and making sure the data shows up in the correct format. So the primary thing related to addressing that we have at layer 4 is ports. And here's a table of some commonly used ports. You should be familiar with these. You know, I think most people know HTTP is on port 80, HTTPS is on 443, SMTP is on port 25, but you need to probably know these others for this class as well. FTP uses 2 ports. Port 21 is the initial establishment of the connection and the authentication if you need to log in. And once you start a file transfer, that happens on port 20. And then down here at the bottom, BootP, which is probably one of the oldest protocols we'll study. Whoever wrote this used 1 port for the server and 1 for the client. And it is very uncommon to split that. So I would maybe chalk that up to they were in the learning phase of this. So again, here's some example port numbers and probably port numbers that you will need to be familiar with.